Today, we will talk about some principles for designing drugs. We will look at competitive inhibitors for this example. Remember, a competitive inhibitor will compete for the same site as the substrate, so it will often look and have the same or similar 3D shape and electrostatic charge as a transition state for the reaction to take place. So here's a typical enzymatic reaction. What we want to do is we want to mimic that substrate and inhibit it. So why do we want to mimic the transition state? Well, if the molecule looks like the transition state, again, having the same or similar three-dimensional shape and electrostatic charge, it will take less energy to bind this inhibitor than the actual substrate. Here's shown the original substrate reaction profile in black. The transition state mimic inhibitor is shown in red. Notice there's less energy required to bind this transition state mimic. Let's go through an example. Proteases are enzymes that cleave the amide bond in a protein. In the active site, there are hydroxyl groups or activated hydroxyl groups that will hydrolyze this amide bond, forming this tetrahedral transition state. To design an inhibitor, and in this case, we're making a peptidomimetic, we want to mimic the shape and electronics of the peptide, placing key electronic groups in the correct areas in space. So I'm going to just show you kind of a generalization. So we're going to mimic one side of the protein as a box, the other as a circle. Notice we put the ammonia group, positively charged, in about the same place as in the original substrate. And we put the carboxylate group in about the same place as in the original substrate. What we want to do now, besides having those boxes and circles with those charges, is we want to mimic the transition state or that tetrahedral intermediate. There are a couple different things that we could do. We could try something called a hydroxymethylene group. Notice in this inhibitor here, we mimic the tetrahedral transition state. We also have our other groups there. We don't necessarily mimic the same sort of charge or electronics. Another type of inhibitor that we could do is using a phosphonate inhibitor. This is probably a little bit better in that it mimics the tetrahedral transition state, but also mimics a little bit better the electrostatics of that transition state. These are just examples of drugs that could be designed as potential inhibitors for this enzyme.